happy to discuss these slides, but...
Or we can swap, but...
So in terms of blurring boundaries while the slides are coming up, my cap comes from EUMETSAT. And it hides a bandage. Okay, thank you very much. So it's a real pleasure to be here with you, either online or in the room. It's a real pleasure to present the work from this strong team dedicated to the real-time retrievals of CO2, carbon dioxide, and methane, CH4, within Copernicus. I'd like to thank, of course, the partners, University of Bremen in Germany, of course, Esron in the Netherlands, and FX Conseil and LMD in France as well. Our role within Copernicus is to feed the analysis and forecasting system maintained at ECNWF for greenhouse gases. CO2 on the left, yes, I think that's the one. CO2 on the left and methane on the right. So those are the maps that were issued 2 days ago, starting on Monday for today. This forecast would have been issued anyway, but our role here is to feed the data, to feed the system with real-time data, to anchor it in reality. So of course, in the scientific community or through space agencies, you could find other retrieval products. The specificity of what we do is that we provide them within a couple of days after the date, which is amazingly stringent in terms of constraint. Passing here. At the start of our service in September 2021, we had a range of products with column average dry mole fractions of CO2 and CH4. So those are called X-CO2 and X-CH4. And also partial columns of CO2 and CH4 that we call here MT for mid-tropospheric columns of CO2 and CH4. We were using GOSAT, the Japanese instrument, and YASIBI, the European instrument. But throughout the lifetime of this service, we are transitioning towards younger instruments, GOSAT-2 and YASI-C. We are also trying to put CO2 data from NASA in the pipeline. Within the rest of this talk, I will describe each one of these products, in particular through the contribution of each partner. So I'm starting here with the column average of CO2 prepared in near real time by the University of Bremen. They have been doing this for many years now, 2014. They have been using an algorithm of their own, which is called BESD. And actually, just a week ago, they have transitioned to their new algorithm called Focal. So I will start with some slides about BESD and then discuss the situation with Focal. Here is the best products that was delivered until a week ago. We have here the example of what was delivered to ECNWF during the month of March. You see here the dots representing the retrievals. You have a lot in the US for that month, a lot in Europe, the southern parts of South Africa, South America, South Africa, Australia. Apart from these regions, maybe India as well, a bit of China. We lack data in the high latitudes, in particular because of lack of insulation. We need sun radiation to have a proper observation, but also close to the cloud systems. So that's what we delivered in near real time. So I would say in a rush, because again, we need to have this very, very fast. And here on this plot, we have the comparison between the time series at the global scale of this in a rush product with the more carefully crafted product archived in C3S. Here, that's the OPS4 MIPS product. It's an ensemble product. And you see here a fair continuity between the red curve and the blue curve in a rush. That's for the global average, but we also have diagnostics at smaller scale as well, showing a good consistency. For near real-time applications, we also need to have near real-time quality control, which is quite challenging. At Bremen, they have in particular, for that purpose, developed a climatological model, SLIM CO2, that allows, well, it's a climatological year, which is propagating in time using the growth rate observed by NOAA. And there is a fair consistency when you look at the column average and large areas like zonal bands. There is a fair consistency between that model in blue and the full-fledged CAMS inversion that I will describe tomorrow. And here in gray, you have the individual retrieval. So there is a good consistency between the retrievals, the two models, and the two models with each other. That happens here at the global scale, but you also have the diagnostics available in latitudinal bands. So that allows monitoring the data to check that everything is running as smoothly as expected. As I explained a week ago, there was a switch to focal. The advantage of focal is obvious from this plot. If you remember the ones that I showed a couple of minutes ago, there is data over the ocean. And we even have more data over land. It's the month of May, so it's not fully comparable. So we have more data in the high latitudes, but the density for the other latitudes is much larger. There are other beauties in focal compared to BEST, but they are not used currently within CAMS, but maybe for the future. Compared to TCON, which is the ground truth or kind of the best kind of the best. There is ERCOR as well. But in terms of data volume, TCON is what we have as a reference. We have good statistics in terms of biases and standard deviation. In blue, you have the historical record, the carefully crafted data. And then in red, you have the in-rush data. And actually, if you look at the statistics, it's marginally worse for in-rush, but not by much. So that's for the GOSAT product with the XU2 values. It would be nice to have what is arguably the best satellite, the data from the best satellite observing CO2 today, which is the one from NASA. The OCO2 system, and we have been at LSE trying to put the data in the box for the last few months. We had made a year ago a demonstration using an artificial neural network system showing that we could obtain an excellent precision and accuracy of the system. Of course, it's very fast. We train on real data, blah, 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 blah. And also what is really nice, as shown here, it's a slice, it's an orbit track that goes through several plumes coming from coal power plants. And in blue, you have the neural network output, and that really shows when you cross the plumes, 1, 2, 3, 4. And in red, it's the operational, it's the official NASA algorithm, ACOS, and you have the same pattern. And what is interesting is that in the training data set for the neural network, there is nothing like a plume from a coal power plant. So it's really something that has been well generated, created by the neural network that has learned from the physics and not just by statistical relationships. There are limitations of our demonstration with respect to near real-time processing. There is the issue related to CO2 that it's constantly increasing, so you need to have a representative data set, even though CO2 beats its own record year after year. So there is an issue there. And also in our demonstration, we had used a cloud detection from ACOS, but we need to have something in near real time as well. So to address the second issue, initially we thought that the threshold on surface pressure would be enough. I'm passing the detail here. But now we, in addition, add a neural network that learned the cloud flag from ACOS, and it works remarkably well. So all in all, at the end of the day, when you combine the neural network that does the cloud flagging, plus the neural network that does the surface pressure and compared to ECNWF, plus the neural network that computes the XU2, well, you get something which is at least as good compared to the NASA algorithm. As of today, we are ready to send the first data, but we have more in the pipeline to extend the data volume. There is a question of gap filling of the radiant spectra, glint observations. There is the question of the exceeding values of XU2. So more will come in the next few months. I'm turning now to methane, the column of methane. We have here all quality-controlled, filtered GOSAT soundings that were sent to ECNWF throughout the year of 2021, so in near real time. So it's the full year, so this time you see the high latitudes, and we also have the ocean as well. Actually, what has been sent to ECNWF is not simply CH4, it's the ratio between CH4 and CO2, because this approach, it's called the proxy approach, is quite fast, and you need to have some information about CO2 to extract the methane itself, the methane information itself. Traditionally, S1 has been working with carbon tracker data, so that's a model system from NOAA. They have been using for the recent past the CAM CO2 forecast, and actually compared to TICON, you have very good statistics in both cases. So there is a good consistency between the two approaches. This is the comparison between the proxy near real-time product that has been delivered to ECNWF and the full physics algorithm. So it's full-fledged, it's more costly, it's kind of the reference that we can have. There are differences between the two, but I would say there is a fair agreement with a mean bias of 20 ppb. So I would like to have something smaller than that. Of course, we all would like to have this. And there are discussions. We are considering the possibility to switch from the proxy system for the delivery to ECNWF to the full physics system. The price to pay is that we will have less data because it's more costly. So that's likely within the next few months. Now I'm turning to the YASI retrievals of CO2 and CH4. This is still about neural networks, but it's a different approach compared to what I showed for OCO2. For OCO2, we were training on real data, and here we are training on simulated data with an empirical bias correction to address the repetitive biases. So that's the work of LMD. In addition to YASI, they are also using the microwave information from AMSU on board the same platform to decorrelate the temperature information from the gas variations. The best products that they can have, given this approach, is in the tropical region. And the kind of product that they provide is for clear sky only, so that's not different from the other products that I showed previously. No clouds, no aerosols. The originality is that they provide data in nighttime as well as daytime. And of course, they have land like ocean. On this graph, it's quite a busy one, but basically what I like to introduce is the climatological signal that we have. I said that we had the best quality of products in the tropics. Here we have the northern tropics, and then in the bottom you have the southern tropics. You have here the time series starting in 2018. You have a marked seasonal cycle in the northern tropics, less marked in the southern tropics. That's what we expect. So that's for CO2. And we have the same here for CH4, but the difference between the northern tropics and the southern tropics is less striking. Again, quality control is particularly important, but also very challenging to be done in near real time. And over the last couple of months, LMD had been working with the quality control to detect abrupt changes. So it's a different approach, but not too different compared to the slim CO2 approach that I mentioned before for the University of Bremen. This time there is no climatology. We fit the data, the recent data, up to the previous day with a simple smooth curve, and we compare the data of the day with this smooth curve. When it exceeds the threshold, then we issue a warning. So that allows you to get a glimpse of the care that we have to send data to ECNWF as good as possible, and if we have a doubt, we try to warn ECNWF, because the quality of the data triggers the quality of the forecast that is issued by ECNWF as well. So with all of this, I hope to have showed you that we have a diversity of products and more in the pipeline that should ensure a stable and robust forecast for CO2 and CH4. So that's our role, and we're happy to do it. Thank you very much.
Thank you, Frédéric. So I think it also shows why the CO2 MBS is with CAMS, because all these activities have been ongoing, and without that, I think we could not hit the ground running when the CO2M will be there. So it's also important to start discussing with the stakeholders and users to not to say simply wait for 2026. We'll have very nice products. We have products already, and what's really nice is this international comparisons and collaboration, which situates Europe and Copernicus very.
And there is a lot of experience that we are gaining to provide data in real time, which is quite unique in the world. So I hope that for CO2M and the massive amount of data that will be delivered to the world, we will play a role, an important role, because of our experience.
Thank you. I see no question. So thank you very much.